One last final note for this lesson. We're not going to use all three of these graphs. I just want to talk about one more important graph. We've already mentioned what y equals 2 to the x looks like. We know that y equals 2 to the x is our exponential growth. The horizontal asymptote here, and the very steep growth there. That's y equals 2 to the x. What I want to talk about next is what y equals negative 2 to the x would look like. We also already know what y equals 2 to the negative x looks like. That's exponential decay. Y equals negative 2 to the x, and hopefully this doesn't surprise you, because it does the same. That negative does the same thing that it's done all year long. It will flip the graph upside down. So every point just gets reflected under the x-axis. So 0, 1 becomes 0, negative 1. 1, 2 becomes 1, negative 2. 2, 4 becomes 2, negative 4. And this is the graph of y equals negative 2 to the x. Notice how it's very important this is not the same thing as y equals negative 2 to the x. We don't graph that. That's not a thing at all. So make sure we don't confuse those. Some of you might be asking, well, is this exponential growth or is this exponential decay? It's not really either, but if it's got to be one, we would call it exponential growth. We would definitely not call this decay. Even though the y value is getting smaller and smaller and smaller, it's not getting closer and closer and closer to 0 as x gets bigger, so we would not call this exponential decay. We know that exponential decay was y equals 2 to the negative x. And just for fun, I guess we will do this last one. Y equals, if we put a negative in front and a negative in the exponent, then this graph is not only flipped upside down, but it's also flipped backwards. So this graph will be both upside down and backwards, and it doesn't even matter which order you flip it in. But it means as x gets bigger, we'll get closer to the x-axis. As x gets more negative, our y value will become more negative.